Okay, this is question 7b, 2017 exam. A particular triglyceride, remember tri means 3, fatty acid, lipid, found in beef, contains 3 different fatty acid chains. This chains, I think, might be important in this question. Palmitic, stearic, and oleic. Compound A, so with its chains, undergoes hydrolysis. So hydro meaning water and lysis meaning break. So we're going to add water to break this molecule up into this molecule here, which hopefully you will remember is glycerol, and these molecules here, our fatty acids. So to break these up, you need water, hydrolysis. So water will be added along here to break the chain. So you will need 3 water molecules for each bond that needs to be broken. So this is going to say 3 water molecules. So the first question says, complete the structure of compound A in the box provided. This seems to be a little bit tricky. So you've got palmitic, stearic, and oleic fatty acids, which are these palmitic, stearic, and oleic fatty acids. When you look in your data book, palmitic, stearic, and oleic fatty acids, the pink ones, they're these ones, which is what's written on here. However, the answer expects these. So I think what they're saying is that they want the chains. It's a little bit unclear whether you have to do the answer like this or whether you can do just these. Either way, you need to be doing it correctly. So this molecule is glycerol, and when you put it with the fatty acids, it will form the triglyceride with an ester bond. So the alcohol and the carboxylic acid get together to make the ester. And then water is also produced. So the opposite happens when you're undergoing hydrolysis. So you need to be able to, if we just picked up this molecule and turned it around, so it says C15H31, so it means basically that there's 15 carbons and each carbon's got 2 hydrogens. So for C15 you'd have 30 hydrogens plus 1 extra for the end. And you've got your carboxyl group and your hydroxyl group. So when these get together you're going to make water. So, oops, by the way, this will come off. And you'll be left with the COO. So the ester pointing in that direction. So I see people, they realise that there has to be an ester bond pointing that way, but then they kind of forget that that this molecule has to be turned around, and they just write, because that's given like that, they just write this bond and then their C15H31, and then they put the COOH on the end again, which is clearly not right. So the molecule is turned around so that it's reacting in this direction. Alright, so this is if you just picked it up and attached it. And a water molecule is produced each time you do that to make the ester. However, the answer has got this chain rather than the really summarized form. So if you took, because there's a CH3 on the end, if you took one of those carbons away for the CH3, then you'd be left with 14 carbons. And if you take 3 hydrogens away for the CH3 on the end, then 31 minus 3, you'll be left with 28 hydrogens. Instead of writing it C14H28, you could break it up to do a semi-structural formula. So it's CH2, CH2, CH2 14 times, so that you had 14 carbons and 28 hydrogens. So they've written this as the semi-structural formula. Rather than stressing out about it, that's also what's written here. So they've got the ester bond, ester group bonded here, and then they're flipped over their CH214, and then their CH3 on the end. Just remember to write the whole thing backwards, flipped over. So you can do the same for the second one, CH2 16 times and a CH3 on the end, and then your ester bond, CH2 7 times CH. So write it backwards the whole way to get the chains. So it's a little bit unclear whether from the question, complete the structure of the compound in the box provided. The answer that's given is this answer. It's a little bit unclear whether you had to write these like this, or whether you could have gotten away with doing it like this. I suspect you have to do it like this, probably because it's mentioned that there's chains. So the second question is write the formula of the compound. So you need water for hydrolysis. So you're adding the hydrogen back to here to make the carboxylic acid, and you're adding the OH onto the ends here to make the glycerol. So it hasn't asked you to name this, but quite often they'll ask you to name what that is. And the fact that you needed 3 of them. So you have to say you need 3 water molecules. So this last question says, draw the structural formula. It's not just any structure, it's the structural formula, which means when you draw the glycerol, you have to show all the bonds. You can't leave off those bonds. All right, the last question is lipase and co-lipase, so coenzyme work together to catalyze. Describe how coenzymes and enzymes interact to catalyze a reaction. So coenzymes are organic molecules. This is from the answers. So I don't think you needed to write that they're organic molecules. Organic molecules meaning that they contain carbon. And they are organic molecules, but they are non-protein. So they contain carbon, but they're not proteins, whereas enzymes are proteins. So coenzymes are organic molecules. So what you needed to talk about how they interact in order to catalyze the function, you needed to say that they become part of the active site and they change its shape. So by combining with the enzyme, they modify the shape of the active site. So you needed this and the fact that the shape is changed when the coenzyme binds. And that, when we're explaining how, the fact that you've done that leads to the enzyme being able to function. So you're looking at what happens, the interaction, and then how that allows the enzyme to work. So just some mention that it makes the enzyme work. So that's the first mark. And then you needed something extra, and they accepted 2 different answers. So a coenzyme may act as a carrier of electrons or small groups of atoms. So it can carry electrons to or away from enzymes or add atoms or groups of atoms. And because it does that, then it facilitates it. Then how does it help you? It helps its action. So I don't think you really needed to say this extra bit because you've already set it up there. But you do need to say this, or a coenzyme assists the enzyme to catalyze a reaction by providing an alternative reaction pathway which has a lower activation energy. So enzymes are basically catalysts. So if you use the catalyst idea that the pathway that it undergoes, the substrate undergoes, has a lower activation energy when you use an enzyme. Okay.